Hi friends, I'm Snehal Patil. Welcome to tutorial series on digital electronics and my topic is logic family totem-pole arrangement used for 2-input NAND gate. We will start with logic family. What is logic family? A range of electronic devices that is made by the same manufacturing technique and provides a number of logic functions. This logic function may include logic gates, flip-flops and counters. Logic families are commonly used are ECL and TTL, which are based upon bipolar transistors, and the NMOS and CMOS families, which are based on MOSFETs. We will see the brief overview of classification of logic families. The logic families are classified into two types. First is a bipolar logic family, second is a unipolar logic family. We will see the bipolar logic family. It consists of again two types, saturated mode and non-saturated mode, depending upon the transistor operation. The saturated logic families are further classified as RTL, that is a resistor transistor logic, DTL, that is a diode transistor logic, DCTL, that is a direct coupled transistor logic, HTL, that is a high transistor logic, TTL, that is a transistor logic, and sixth one is a integrated injection logic. In the same manner, non-saturated logic family has Schottky TTL logic family and emitter coupled logic. Now we will see the unipolar logic family. The unipolar logic family make use of MOSFET devices which are already unipolar devices, and hence this type of family is called as a unipolar logic family. It consists of three types: PMOS, NMOS and CMOS, where PMOS stands for P-channel MOSFET, NMOS stands for N-channel MOSFET and CMOS stands for complementary MOSFET. Our basic topic is totem-pole arrangement with a 2-input NAND gate. We will might be thinking, what is a totem-pole and why the name is totem-pole? The output stage of is known as a totem-pole stage because it has three components which will be shown in the circuit diagram. Here, the transistor T3 is placed on transistor T4 and hence such a type of arrangement is called as a totem-pole arrangement. Here, the transistor T3, transistor T4 and diode D are stacked together and are present in the output stage. So this output stage is known as a totem-pole output stage, and we are taking output from this terminal. We will see the circuit diagram. It consists of transistor T1, transistor T2, transistor T3 and transistor T4. Transistor T1 is called as an emitter coupled transistor because it has an emitter terminals which more than one, and when there are if suppose there are two terminals, then it is called as a 2-input NAND gate. Here the number of emitters are equal to number of inputs. Suppose my transistor T1 consists of 3 input terminals, then it is called as a 3-input NAND gate. Here transistor T2 acts as a switch which will either turn on transistor T3 and make transistor T4 turn off, or vice versa. Now we will see the equivalent circuit diagram of the previous circuit. As I said, the transistor T1 used in this section is emitter coupled transistor. The equivalent circuit of emitter coupled transistor is shown in the figure. It consists of diode D2, diode D3 and diode D4. As I said, the transistor T2 acts as a switch and transistor T3 and T4 forms output stage. Now we will see the turning action of transistor T2. In order to turn on the transistor T2, the diode D4 should be forward biased. The diode D4 will be forward biased when the anode of diode D4 is at logic 1 level and the cathode will be at a potential 0. When these conditions are true, then transistor T2 is turned on. In order to turn on transistor T2, the voltage requirement will be such that the voltage across diode VBC plus voltage across base emitter junction of transistor T2 plus voltage across base emitter junction of transistor T4 should be equal to 2.3 volt. When the base voltage at Vx will be 2.3 volt, then and then only transistor T2 will be turned off. As we are studying the NAND gate, For NAND gate, when any one of the input is 0, then the output turns to be 1. And suppose when both the inputs are at logic high level, then output turns to be 0. Now we will consider the first case where the input A equals to 0 and B equals to 0. When A equals to 0, the cathode will be at 0 potential, but anode will be connected to the plus 5 volt supply. So the diode D2 and diode D3 both are forward biased. Hence the diode D4 will be reverse biased, as the anode of diode D4 is connected to the logic 0 level, and so the diode D4 is forward reverse biased. As diode D4 is reverse bias, so there will not be any bias for transistor T2. The voltage requirement is 2.3 volt, and hence transistor T2 will be turned off. As transistor T2 will be turned off, there will not be any emitter current IE, there will not be base current for transistor T4, and there will not be any voltage drop across resistor R4, and hence there is no bias for transistor T4, and hence transistor T4 is turned off. Now we will consider the above stage where the plus 5 volt supply provides the current IC2, also it provides current IC3, and there will be a current flowing through the base terminal of transistor T3, and hence transistor T3 is turned on. As transistor T3 is turned on, the diode D1 also turned on, and hence the output of Totem-pole stage will be connected to the plus 5 volt supply, that is a high level. Hence when the input terminals A and B at logic 0 level, then the output turns to be logic 1. Now we will consider the second stage where the A equals to 0 and B equals to 1. When A equals to 0, again the diode D2 will be forward biased, as the cathode of D2 will be at 0 potential and anode is connected to the plus 5 volt supply. But in case of D3, when B1 is equals to 1 and anode is also logic 1, so the diode D3 is reverse biased. But diode D2 is forward biased, so D4 remains on reverse bias, as the anode is at logic 0 level, and hence the transistor T2 is turned off. As transistor T2 is turned off, there will not be any bias for transistor T4. As I earlier said, there will not be any emitter current, no base current, and no voltage drop across R4. So transistor T4 remains in the off condition. But plus 5 volt supply provides the base bias to the transistor T3, and hence transistor T3 is turned off. Hence the output level of this circuit is equals to logic high level, as transistor T3 is in the on condition and D1 is also in the on condition. So the output turns to be 1. Hence when A equals to 0, B equals to 1, then also output remains 1. When A equals to 1 and B equals to 0. As B equals to 0, the diode D3 will be in the forward biased, as a cathode of diode D3 at logic 0 level and anode is connected to the plus 5 volt supply. Hence the anode of diode D4 will be connected to the logic 0 level, and hence T2 remains up, no current through IE, no base bias for T4, and hence no voltage drop across the resistor R4. So T4 again remains in the off state, but plus 5 volt supply provides the base bias for transistor T3, and hence it is turned on. As T3 turned on, D1 turned on, and hence the output pin is pulled up to the plus 5 volt supply. So when A equals to 1, B equals to 0, again the transistor output turns to be 1. Now we will consider the last test where A equals to 1 and B equals to 1. As A equals to 1, B equals to 1, cathode is at higher potential than the anode, and hence D3 and D2 will reverse bias. As D2 and D3 are reverse bias, the anode of diode D4 directly connected to the plus 5 volt supply, and hence diode D4 is turned on. As diode D4 is turned on, the base bias condition for the T2 will be true, that is a 2 point sufficient voltage is applied at transistor T2. So here Vx is get applied, which is equals to 2.3 volt, and hence transistor T2 is turned on. As transistor T2 is turned on, there will be emitter current, there will be the base current, and hence there will be a voltage drop across R4 resistor, and hence transistor T4 is turned on. Now we will, as plus 5 volt supply provides the current IC2, but there will not be sufficient current for the transistor T3 or sufficient voltage for transistor T3 to be turned on, and hence it remains in the off condition. As there will be voltage drop across R4, the T4 will be turned on, and hence the output pin get connected to the 0 level, and hence when A equals to 1 and B equals to 1, and then also output becomes 0. Hence the truth table for NAND gate is verified, as when A equals to 0, B equals to 0, output equals to 1. When A equals to 0, B equals to 1, then also output is 1. And when A equals to 1, B equals to 0, output is 1. And when both the inputs are high, then output turns to be 0, which are confirmed by the previous circuit diagram. Now we will see the applications of totem-pole arrangement. They are basically used in computers, industrial electronics, test equipments and instrumentations. Oh, to make your concepts more clear, you have to do homework. Now I will assign you homework. Just I have explained the classification of logic families. You must go through all these logic families and make your concept more clear. The totem-pole arrangement comes under the TTL logic family, which also consists of tri-state logic or many more things. Just go through that and have a brief overview of all the things. So thanking you and enjoy your homework. Thank you.